Okay, let's talk about infinity for a second. Have you ever tried to wrap your head around adding up an infinite number of things? I mean, it sounds completely impossible, doesn't it? Like trying to count every single grain of sand on a beach. But what if I told you that sometimes, just sometimes, you can actually tame infinity? That you can add up an endless list of numbers and get a single, simple, finite answer? Well, today, we're going to find out how. So, to get our heads around this, let's start with a classic puzzle. Picture a rocket launching, trying to get to a satellite. In the first minute, it covers half the distance. Okay, easy enough. In the next minute, it covers half of the remaining distance. And in the minute after that, you guessed it, half of what's left. And it just keeps doing this forever and ever. And that leads to the big brain-twisting question. Does our rocket ever actually get there? I mean, is it trapped in this endless game of having the distance, always getting closer but never ever reaching its final destination? Stick with me, because the answer to this is surprisingly elegant and it's going to unlock this whole idea for us. So here's our game plan for this explainer. First, we'll unpack this infinite puzzle. Then we'll talk about the two possible fates of any infinite journey. Does it converge or diverge? After that, we'll meet a special kind of series we can actually solve, learn the trick to adding it all up, and finally see where this mind-bending math pops up in real life. All right, first up, the infinite puzzle. How in the world can we add forever? Well, in the world of math, what we're talking about is called an infinite series. It's really just a fancy way of saying we're adding up all the terms in a sequence that never, ever ends. You know, that first half of the rocket's journey, plus the next quarter, plus the next eighth, plus the next 16th, adding up every single one of those infinitely shrinking steps. Now it turns out that every infinite journey, like our rockets, has one of two possible destinies. And this is where we have to ask, does it converge or does it diverge? On one hand, a series can be convergent. This is like our rocket perfectly settling into a stable orbit right at the satellite. The sum of all its infinite little steps actually adds up to a single finite number. But on the other hand, a series can be divergent. And this is the rocket that misses its target and just flies off into deep space, its total distance just growing and growing forever with no limit in sight. You know, here's a really simple way to think about it. A convergent series is like a journey with a clear destination. A divergent series, well, that's a journey without any end. And our whole job right now is to figure out which kind of journey our rocket is actually on. So, how do we tell the difference? Well, we've got to look for a pattern. And that brings us to a very special, very powerful type of infinite series that we can actually work with, the geometric series. What makes a geometric series so great is that it's beautifully predictable. To get from one number in the sequence to the next, you always multiply by the exact same fixed number. And this special number has a name. It's called the common ratio, and we're just going to label it with the letter R. And let me tell you, R is everything. This one little number is the secret key that unlocks this entire puzzle. It tells us, point blank, whether our rocket reaches its destination or just flies off into the void. Honestly, it's the single most important piece of information we're going to need. And finding R is super easy. Seriously, you just pick any number in the series, doesn't matter which one, and divide it by the one that came right before it. That's it. The number you get is your common ratio, R. Simple as that. All right, we have defined the problem, we have found our secret key. Now it's time for the main event, summing the infinite. This is the moment where we get a real, concrete answer from an endless list of numbers. So here it is, the one magic rule that governs everything. A geometric series will converge. It will add up to a finite number, but only if the absolute value of its common ratio, R, is less than 1. Think about it. If each step is getting smaller, the journey has a destination. But if R is 1 or bigger, then each step is the same size or even larger, and that total distance just runs away to infinity. And for those times when it does converge, well, we can find its exact sum with this stunningly simple formula. The sum, which we'll call S, is equal to A, that's just the very first number in the series, divided by 1 minus our common ratio, R. That's the whole trick. Let's see this thing in action. Take that first series, 8 plus 4 plus 2, and so on. Our first term, A, is 8. To find R, we can just divide 4 by 8, which gives us 1/2. Now, since 1/2 is definitely less than 1, we know it converges. So the sum is 8 divided by, in parentheses, 1 minus 1/2, which gives us a grand total of 16. But now look at the second one, 2 plus 6 plus 18. Here R is 3, and since 3 is way bigger than 1, the numbers just keep exploding. This series diverges, it has no sum, It just runs off to infinity. Okay, so this is some really cool math, but where would you actually see this stuff? Well, let's get to our final section, infinity in real life. And believe it or not, we're going to look at something you've probably known about since you were a kid. Think about a repeating decimal, like 0.333 going on forever. It seems pretty simple, right? But have you ever really stopped to think about what it is? Well, it turns out it's a secret, hidden, infinite geometric series in disguise. I mean, if we just break it down, the pattern becomes crystal clear. Point 0.3 repeating is really just point 0.3 plus point 0.03 plus point 0.003, and so on, forever. You see it? Each new number we're adding is just the previous one multiplied by 1/10. We have ourselves a geometric series. And now we can use our tools. The first term, a, is point 0.3. The common ratio, r, is point 0.1, right? Since each term is just 1/10 of the last one, and since point 0.1 is absolutely less than 1, we know it converges. So we just plug those values into our formula. The sum is point 0.3 divided by, in parentheses, 1 minus point 0.1. So what does that give us? Well, point 0.3 divided by point 0.9, which simplifies to 1/3. How amazing is that? We just use the logic of an infinite sum, this massive mind-bending concept, to prove that point 0.3 repeating is the exact same thing as the fraction 1/3. Which kind of leaves us with one final thought, doesn't it? If something as common as a repeating decimal is secretly being powered by the mathematics of infinity, what other beautiful, hidden mathematical patterns are just waiting out there for us to discover? I mean, from the weird repeating shapes in fractals to calculating financial models that go on forever, what else can we understand by learning how to tame infinity?